How many perfect squares are divisors of the product 1 factorial, 2 factorial, 3 factorial, all the way up to 9 factorial? So 1 factorial times 2 factorial times 3 factorial, all the way up till 9 factorial. I'll write it all out. So that's basically what all of that means. Now each of these, I want to combine individual digits here. So 9 only appears once, so it's 9 to the power of 1. 8 appears twice, so that's 8 to the power of 2. 7 appears 3 times, so that's 7 to the power of 3. So you kind of get the hang of it. 6 appears 4 times, and so on. 5 appears 1, 2, 3, 4, 5 times. 4 appears 6 times. 3 appears 7 times. 2 appears 8 times. And finally, 1 appears 9 times. Okay? So I hope that made sense. Let's move this up a bit. So now what I want to do is I want to break up each of these into its prime factors. So 9 is basically 3 to the power of 2. 8 is 2 to the power of 3. But don't forget it's to the power of 2. 7 is already prime. 6 is basically 2 times 3, all to the power of 4. 5 is already prime. 4 is 2 times 2 to the power of 6. 3 is already prime, and 2 is already prime. And the 1 is just 1, so that's not really helpful or needed. Now we've got it all prime, so let's do that. We got 3 to the power of 2, 2 to the power of 6, 7 to the power of 3, 2 to the power of 4, 3 to the power of 4, 5 to the power of 5, 2 to the power of 6, 2 to the power of 6, 3 to the power of 7, and 2 to the power of 8. Now comes a very important step. We have to combine them. So 2, 6, 4, 10. 6 is 16, 22, and 30. 2 to the power of 30. All right? 3, we've got 2, 4, which is 6, and 7. So 13 there. And then what's the next one? 5. 5 is just 5. And then 7, we've got 3, and that's it. There's 3. Okay. So this is, we took basically this guy and brought it all the way down to here. Okay? Now, what is the question asking us? They want you to basically, how many perfect squares are divisors of this? So how many perfect squares are divisors of that? Well, a perfect square basically has the following form. 2 to the power of 2a, if we were to use these bases. 3 to the power of 2b, 5 to the power of 2c, and 7 to the power of 2d, right? It's a perfect square. So if you take the square root, it has to give you a number. Now, if we compare the exponents, right, you'll see that 2a, the maximum it can be is 30, and the minimum, of course, it can be is 0. So that means a is between 15 and 0. Okay? For the b's, if you compare that to the exponent that the base 3 has, you'll see that b, or 2b rather, is between 13 and 0. So that means b has to be between 6 and 0. B can't be a decimal, right? It has to be an integer. It's an exponent. And then similarly for 2c, 2c has to be between 5 and 0, and therefore c is between 2 and 0. And finally, if you look at 2d, 2d is between 3 and 0, so that means d is between 1 and 0. So how many possible values do we have for a? Well, we've got anywhere from 0 to 15 inclusive, so we have 16 possible values for a. For b, any integer from 0 to 6 inclusive, so 7 possible values. For c, we've got 0, 1, or 2, so that's 3. And for d, we have 0 or 1, so that's 2 possible values. So to figure out the total possible combinations, or rather perfect squares that are going to divide into that are of this form, we would figure out that by multiplying these. So it'd be 16 times 7 times 3 times 2, and that is 672. So the answer to number 23 is B.